flat dimension like this. We have 3 different views. But now we're going to help explain how we get to that 2-dimensional print. Okay? So that's where the orthographic and the glass box theory comes in. Okay? So the glass box shows how different views are projected or created. As you can see, we have 3 different parts. We have a top, a front, and a right side. So if we were to fold that glass box up, now it becomes 2-dimensional. Okay? And the front will come to the front glass. Your side view will come to this side. And the top will be displayed on the top section. So it's a lot easier to describe that in that manner than it is to sometimes have to turn a print around or have 5 different sets of prints. Because you might have to look at the top, the front, and the side all together, and if you're constantly switching back between 3 different prints, it can be very confusing and waste a lot of time. So we have this box here. All we basically do is fold it up, so now it becomes 2-dimension, and this piece would fold out the same way as this. Okay? Now we just made it a 2-dimensional piece from 3 dimensions. That's all our glass box is really. The glass box method is projecting on us. Okay? And here it shows you how they basically bring the front view to be seen as a 2-dimensional part in the beginning. If you notice, all your points stay the same. A, D, B, and C. Okay? So especially when you start reading prints, there's a million different methods out there. A lot of people have their own little tricks and so forth. What I really want you to focus on is just staying consistent. Okay? The more and more you read prints, you'll start to understand different portions of it. So I almost always start in the bottom right-hand corner. I'll read my title block, start making sense from there, and then I will go up and I will start reading. I read my front view first, then my top view, and then my sectional view or my side views. I don't really care if you do it side view, then top, and then bottom. What I want you to do is just be consistent. The more and more consistent we are, we create our own habits. And as long as that works for us, that's fine, as long as we're getting the correct information. Okay? Here's just another example of the top being projected, the object's top surface being projected to the top of the glass box. Side, same thing. I think we understand that portion fairly well. This was just showing you a simple isometric view, shows how an object would appear in 3 dimensions. They're very helpful when you're trying to figure out what it's supposed to look like. Because from this spot over here, you have to be able to visualize this portion. And a lot of the prints now will give you an isometric view first, and then they'll also give you, or another sheet with an isometric view, and then you will get your 2-dimensional view as well. Don't you agree, Dan?
Yeah, and one other thing too is sometimes you will get an assembly drawing with your packet of prints, which helps to be able to visualize just where this part's going to fit in the tolerances required.
Okay. So, example, what Dan's saying is this is just one portion, right? So now say there's 2 of these, and they're designed to fit together so that you have 2 pieces and one of them fits on top. And say they're a shifting block or a bearing, floating bearing, so to say. Okay, these may be made out of Teflon, and they're designed to glide on each other. So Dan's saying that what you'll get is an assembly view or print as well that will show you how these 2 pieces are supposed to fit together. And then you'll notice that you might start seeing differences like tolerances in between as well. Okay? All right. Let's move through this section. Let me take a look here. So feel free to read through your book. Page 204, 205 talks about the glass box. Shows how different views are projected. We are over on page 206 now, on the view arrangement, which is the top right-hand column of that page. Okay, so what it says here is after the views are created through orthographic projection using the glass box method, the hinge box sides are open completely to show the position of the three. So that's what it's trying to show you here. Okay, let me zoom in a little bit. Is that all they're doing is just unfolding this box. We've got our right hand side, which is our isometric view. Here is showing our unfolded section as well. Okay, so as you can tell, here's your front view, this piece. Okay, top view here, and then it's giving you a portion of this which is shaded. Left hand view on the back side, BV on the back view. So you have to learn how to look through this glass box here and recognize that this BV is actually on the back side, the opposite side of FB. Okay? All right. So now let's start getting into some actual prints. Okay. First things first, let's look at our title block. What that's telling us. Job duty 2.7, surface grinding operation, cold rolled steel or mild steel. Designer is DK 111101. Full scale. Sheet 1 of 1, so there's only one part to this print. You may get 5 of them like we were talking about. 1 might be your two-dimensional, 2 might be your isometric, 3 might even be an assembly portion. Here's our tolerance box that we worked with a little bit ago. Okay. Over here. So the way it was described to me, which I always thought was really good, was the big print giveth and the little print taketh away. Do not forget to read the small print, your notes. Right here in this note, right in the center. Do not scale the drawing. You're reading the measurements off of the print. Okay? We come up here to the top. Same thing. Updated drawing and title block. It was revised in 05, approved by LW. So for some reason, 4 years later, the original designer was 01. 4 years later, they did a revision to this. The original print, going from there. Okay? So what it's showing here, left-hand column is the front view. Okay? Right-hand side is your right side view. Your top view here to the top left. Okay. So real quick, let's break down a few of these parts since we're here. We'll start here at the front view. Okay, you can see on the left-hand side that dimension is 0.187 plus or minus 2/1000 of an inch tolerance. Okay. 2 coplanar surfaces, 1/1000 of an inch as well. This side over here, 2x 0.990. So that means 2 times, 2 sides are going to be that exact dimension. Okay?
So, 2 sides. This side and this side.
Help clarify that. Okay. We'll get into the hidden lines and everything else here in a few minutes. But we're just starting to try to break down the individual prints as we're going through this PowerPoint presentation. And the more you see of it, the more and more it'll help you understand as well, okay? So as we can look on this right side view, okay? First things first, start at the top or the far right. We're at a 45-degree angle between here to here, okay? Now, I know it doesn't come out here to this point. That does not matter. This angle is still 45 degrees all the way across, okay? Break it down here to the steps in the center. They are both 0.375 inches. It does not give us a plus or a minus on that. However, if we go down to our tolerance zone, part of our title block, we're at 1/1000th of an inch plus or minus. So we could be 376 down to 374, okay, on both of these sections. Same thing here. Our measurement from this point to the top of this is going to be 0.250 plus or minus 1/1000th, so 2/1000ths accumulation from 0.249 to 251, okay? All right. We'll get into the feature frames here in a few. I don't want to confuse you with those quite yet. We'll eventually get there. I just want you to kind of be comfortable with the actual blueprint portion to start with before we start breaking down the feature frames, okay? All right, let's look at the top view. We can see the center, 0.550, same thing, 3 decimal places plus or minus 1/1000ths, okay? Right-hand column, 1.490, top to bottom, 3 places as well, so the tolerance is 1/1000th of an inch. I think we're kind of getting the hint of it. Again, repetition makes you much better, more comfortable by far. All right, so now what we're going to do is we're going to break down the individual lines. We're going to take a break. We'll come back to this section here in a few.